Hi everybody. I wanted to introduce you to the whiteboards and some of the laboratory components that you'll be using in the CMP EN 270 class this semester. Uh, this will be an introduction and it'll be your first lab that I'm going to have you try on your own. To start out, I'd like you to take a look at what I have here. I have 3 boards, a full-sized breadboard, looks like this. And here I have your LED assembly that you already created. I have a separate video that tells you how to get this together. And on another small board, I have your switch assembly, your 6 switches. And you'll be using all 3 of these boards throughout the semester. I want to start out by talking about the boards in general. I don't know if you've ever used these whiteboards before, but let's talk about continuity. What's connected? Well, if you take a look, there's a red rail. There's a red rail that goes across the top here, and there's a red rail that goes across the top here, or the bottom here. And then there's a blue rail that goes across the top here, and there's a blue rail that goes across the bottom down here. Continuity is in everything that goes across the red rail. In other words, this is connected to this point, which is connected to this point, which is connected to that point. Same thing with the blue, and the same thing with the red at the bottom and the blue at the bottom. Connectivity, as you lay this board out like this, horizontally, is the horizontal connections here on the rails are connected together. Now, what about the center part here? This center part here, the connectivity is different. This point isn't connected to this point. These horizontal points aren't connected. The only thing that's connected are the verticals. So let's point out some verticals here. If you take a look here, these are all connected, and these are all connected across this trough, but these are not connected to those. In other words, there's no connectivity between here and here. So vertically, when you look at this, these points, all 5 of these points are the same point electrically, and all 5 of these points are the same point electrically. But this upper side of the trough is not connected to the lower trough, the lower side of that trough. And that's going to help us when we insert our integrated circuits. So the orientation of your boards are always going to look like this. I'm going to have you put the main board at the bottom. I'm going to have you put your LED assembly board at the upper left, and at the upper right, you're going to have your switch assembly. And you have to get these connected together electrically. These all have to be connected together electrically. Now, I have some handouts that I'll be providing to explain all this, but in this lab, I want to make it really clear to you that you're never going to use the top blue rail in any of these boards, and you're never going to use the middle red, the inside, or this inside red rail. The only rails you will use on these boards are the outside red rail and the outside blue rail. Here, the outside blue and the outside red at the bottom. On your switch assembly, the outside red and the outside blue. The reason is because I don't want you to short things out. These are too close together. So you'll never use the inside blue and inside red on any of these boards. Your 5 volts will always be on the outside red, and your 0 volts, which is ground, will always be on the bottom blue. So, laying out the boards, the red rail on the large board goes at the top. The blue rail on your LED assembly goes at the top. And when you lay out this switch board, your data switch board, I want to make sure that it's positioned vertically, and you'll see why as we go through the labs, and this red rail is to the left. So make sure that you lay those out that way at the beginning of every lab. Now, you're also going to have a power supply module. It's going to look like this. This is not very fault tolerant. If you're not real careful, you end up blowing this up. Now, I gave you an extra one in your kits, but you won't need it unless you destroy this one. You have to be really, really careful, and I'm going to go over those points with you on how you can protect yourself from blowing up this power supply board and damaging it. It's $3, so if you damage it and you use the other one and you blow up that one, you're going to have to spend $3 and get another one of these on Amazon, most likely. But I want to go ahead and I want to insert this power supply board. And if you take a look, this 9-volt adapter is going to go up to the right. I'm positioning it like this, where the 9-volt adapter is up here to the right. And that's where this is going to get plugged in, your 9 volts for power from your 110 socket. And then this gets inserted only in the main board. And I put it way at the end. In other words, I want you to take a look. I'm taking way at the end here. And I'm inserting this. I don't know how easy you can see this, but I'm inserting it at the very end, very carefully, in its position like that. And I have it turned off right now. If you push the button, you'll see that it turns on. But I want to keep it off. You never build your circuits with this on, because you'll damage the circuits. You could damage the circuits. So the first thing we're going to do is we're going to electrically get these boards connected together. So I end up giving you 4 pieces of red 15-inch wire. I got 4 of them. You're going to take one and you're going to connect this rail, the 5-volt rail right there. Now this power supply here puts 5 volts on this top rail when it's turned on. And I need to get that over here. Be careful. It has to go to the red rail over here, which is this point right here. So I just tied VCC, or plus 5 volts, from this rail to that rail. So these are connected electrically with plus 5 volts, which we call VCC. And then I'm going to get another long red wire, and I'm going to continue the process and take that rail here on the LED assembly, and I'm going to run it over here to the red rail on my data assembly, my switch assembly that looks like that. And you can bend these around a little bit just to get them out of the way, maybe a little bit like that. So now when I turn this on, I got 5 volts here, I got 5 volts across here, and I got 5 volts the whole way down here, biasing up this rail and this rail and this rail. Now what about ground? I have black wire. I provided you with 4 pieces, so you're only going to use 2 of them here now, of 15-inch black wire. So what I'm going to do is I'm going to go from the ground rail here. This power supply here puts 0 volts or ground on this bottom row the whole way across here. I'm going to distribute that the whole way up to the blue on this upper board. Plug it into the blue up there. You have to be careful. So I don't know if you can see that, but I have that plugged in at the very top on the blue rail there. And now I have to continue that and distribute it here. I could go from down here up to this point, but I want to keep wires out of the way of my main circuit board. So I'm just going to get another black wire, and I'm going to go from the black rail, the blue rail, the ground rail, and continue that over to here. So now what I've done, you can keep moving these around. I made these long so you can orient these differently. You can pull them out to give you more space, but I'm going to keep it together so you can see it on my video here. So you'll move these wires out of the way a little bit when you're working on it. But now what I did is I distributed the ground from here to the blue and to the blue rail over here. I want you to take a look at that very, very carefully, because you have to set it up this way every time. You have to get these set up this way every time before you start your lab. And make sure your power supply is turned off when you do it. Then what we're going to do is we're going to get into our kits here, and you'll have kits with chips, and I want you to pull out the hex inverter chip. It's going to be the 7404 listed. So you'll see these are laid out on your conductive foam. So you want to get a 7404. So let me pull out the 7404 here. Make sure I get it. Okay. A little difficult to read, but you just sort of take your time. Let's see if I can't see which one's a 74. Yours are all going to be in order, so you won't have any trouble finding the 7404. So I got it. Now, on these integrated circuits, some of them are 14-pin packages, and some of them are 16-pin packages. They have the 7404, which is the hex inverter, has 7 pins on this side, and on the back side here it has 7. And there's a notch here. I don't know if you can see it, but there's a little notch right here. That notch allows you to identify pin 1 down here to the bottom left. So this goes pin 1, 2, 3, 4, 5, 6, 7, and then it goes to pin 8 over here, 9, 10, 11, 12, 13, and it goes to pin 14. Always insert those chips very carefully in the main board like that. Make sure your notch is always to the left, pointing to the left on every chip you put in here. On some of these labs, you might have 5 chips across there. If you put these in backwards, you'll draw excessive current, you'll blow up your power supply. You have to be real careful with that. Make sure you insert these chips, you identify the notch, pin 1 and the notch always point to the left. The next thing I'd like you to do is I'd like you to get a small red wire, and you'll have the red wire to do this, a small piece of red wire, and I want you to get pin 14 of this particular chip, and I want you to take it to VCC, or to plus 5 volts. Now you could jump it anywhere on that rail. You could jump it anywhere on this rail, but I like to keep it directly vertical, just so it keeps things organized a little bit. And then you're going to get a small black or blue wire. I don't care if you get black or blue, and I want you to get the ground pin, which is pin 7 in this chip, like that, and I want you to connect it to the 0 volt rail or the ground rail directly below like that. Now, how do you know that pin 14 was plus 5 volts, and how did you know that pin 7 was ground? Because you'll have TTL specifications that I'm going to send you that look like this. It's National Semiconductor's manufacturer's data sheets, TTL specs. This is going to be put in your in the back of your notebook. I want you to print it out, get it printed out, double-sided if you would. I'll try to do it for you. But I'd like you to get it at the appendix or the very back of your lab notebook so you have it available. And if you get on page 275 in there, and you're going to get really familiar with this quickly, there is the hex inverter. It has 6. It's called hex because it has 6 of these inverters in there. Hex package. We're only going to use 3 of them in this lab. But look, pin 7 is ground. Pin 14 is VCC, plus 5 volts. That's how I knew to bias that chip up, with pin 14 going to plus 5 and pin 7 going to ground. Now, when I turn this on, I'm not going to turn it on yet, that chip will be biased up. It'll be ready to go. It'll be functional. What you're going to have to do in all your labs starting next week is you're going to have to put your chips in, get your boards laid out like this, get them tied together electrically, put your chips in and get your chips biased up. I didn't use any white wire. I didn't use any green, any purple. I just used red wire for VCC, and I used black wire for ground. I always want you to use red wire for VCC. I provided it to you. And I want you to use black wire or blue wire. You can use blue or black to signify ground. I want you to get in the habit of doing that, because when you have trouble with your labs, it'll be very easy to troubleshoot. A lot of students, they'll end up missing this by one. This is hard to see, and they won't bias this up, and their circuit's not going to work. You have to look these over very carefully and make sure that you're going to the correct pin on that IC. If I had a face-to-face class with you, I'd be able to take a look at this real quick and see if these are biased correctly. I'd go 14, ground, it's biased, everything's biased okay, right? Then what we're going to do is we're going to build a circuit in this first lab. What I'm going to have you do is take the hex inverter, and I'm going to have you build up a circuit. Well, what circuit am I going to have you build? Well, I'm going to have you do this. I'm going to start out by building a really simple circuit using just this first hex inverter. I know pin 1's the input. I know pin 2's the output. These are called pinouts. These are called pinouts. You have to write the pinouts on every schematic you do for me in lab this semester to get full credit. You have to get in. Now, where do you get those at? Well, you get them from the data sheets. Pin 1 is an input. Pin 2 is the output for the first inverter. Pin 3 is an input. Pin 4 is an output for the second inverter. Notice on the back side, they're switched. Be careful. Pin 8 is not the input. Pin 9 is the input, and pin 8 is the output. You have to use these. These TTL specifications are going to be your Bible this semester in CMP EN 270. So how are we going to build this circuit? First thing I want to go is I want to go from switch 1 to pin 1. I'm going to go from switch 1 to pin 1. Now I gave you 15-inch white wires. So I gave you some nice long 15-inch white wires. And you're going to take one of them, and you're going to go from pin number 1, and you'll see where you're going to go from pin 1 right here. You can use any one of these, matter of fact. You can use it. These are all connected, don't forget. So I can take any one of these, that's pin 1, and I have to go to a switch 1. So I'm going to tie that, click that to switch 1, and that's why switch 1 is the middle section up here. I don't know how easy you can see it. Let's see if I can show you this. I explained this before, but there's switch 1, and when it's down, you have a 0 volts. When I push this slide switch up, I'll have a plus 5 volts on the output of the switch. The output is the center pin out of these 3 pins. There are 3 pins here. So I'm just going to go the output of that switch to pin 1, and then I'm going to take another white wire's data, and I'm going to go from the output, which is pin 2, and I'm going to take pin 2 to an LEDA. So I'm going to take it up here to LEDA input. So, what did I just connect here? Well, let me show you. I put this wire in right here. I went from switch 1, and I ran it to pin 1. Where's that wire? That wire right there is pin 1 right here that goes over to switch 1. So when I throw switch, it'll provide either a 0 volts or a 5 volts on the input of that inverter. And then, what about pin 2? I didn't take pin 2 the whole way over to this next inverter yet. That's coming. I just ran it up here to LEDB. No, I'm sorry. I took pin 2 and I ran it to LEDB. Let's get that correct. I want to make sure I run that to LEDB, not LEDA. You'll see why in a minute. I'm going to run that to LEDB. It looks like that. All right. Now, notice what I have done. I got switch 1 to pin 1, and pin 2 I took up to LEDB. I took up here to LEDB. Now, just so I can see what's going on, I'm going to take either switch 1 to pin to LEDA or pin 1 to LEDA, because I want to see what's happening with LEDA, with the input here. So I'm going to go from I'm going to put a wire in that'll go from pin 1 up to LED A. And again, it's data, and I have plenty of long white wire for data. You use white wire for data, and I'm going to go from pin 1, right here, pin 1, and I'm going to jump that up to LED A. Now you know why I decided to keep LED A open. Because LED A is going to be the input, and LED B is going to be the output. So let's take a look at my circuit before I turn it on. My circuit looks like this. First of all, I got gone from switch 1 to pin 1. And here it is. From switch 1, I have a white wire gone to pin 1. Now, you're not going to have enough white wires. I mean, the long wires, the long white wires always go to LEDs and go to switches. But to make interconnections down on the board, you can use any color you want with the exception of blue, black, and red. Blue is and black are always signifying ground. Red is always +5 VCC. Any other color you can use for data, but I'm using the white now to jump to switches and to LEDs. Okay, what else do I have here? I have to go from pin 1 up to LEDA. Here's pin 1, and that wire runs over there to LEDA. What else do I have? Pin 2, I have to go to LEDB. That's the output. Pin 2 comes up and goes to LEDB. Now, let's see how this circuit works. I'm going to turn it on by pushing the main circuit board. I want you to notice something. I just turned this circuit on, and switch 1 is low. I have this slide switch up here, and switch number 1, I have it down. So that puts a 0 on the input. So I have a 0 here, which keeps LEDA off. And a 0, the inverter makes it a 1 out here, which is +5 volts, which takes LEDB to a 1, which is 5 volts, just turns LEDB on. The circuit's working the way I expected it to work. If you take a look at the LEDs there, it's sort of hard to see, but the LED is on here. Let me see if I can't turn off the light here to see it a little better. There you go. That LEDB is on. Now, let me throw switch 1 low. Switch 1 high now. I'm going to throw switch 1 high. So what happens when I threw switch 1 high? Well, what should happen is when switch 1 goes high, this goes to LEDA should come on, LEDB should go off. And that's exactly what happened. LEDA is on, LEDB is off. Now let me turn this off here. And let me just go ahead and let me build real quick. Let me go from pin 2 to pin 3 to get this second inverter in. So I'm going to get a white wire, and I'm going to go from pin 2 to pin 3. I don't need a long. It could be any color except red and black. I'm going to go from pin 2. Be careful. You don't want to short anything out and damage your power supply. Notice I turned the power supply off. So here I go to pin number 2, and I jump that to pin 3, which is the input of the second one. I'm getting this all off the specifications. You have to have your specs out to see this. I went from pin 2 to pin 3. Why did I do that? Because I'm coming out of the first inverter, and I'm taking it into the second, pin 3. Now, pin 4 is going to be the output of the second inverter, which I want to run to LEDC. So I grab my long white wire. I go to pin 4. Any one of those 4 I can plug into. So let me go to pin 4 now. That's the output of the second one. And I'm going to take that to LEDC. Take it up here to LEDC. There you go. Let me turn off the light here. Turn my circuit back on. Do not build these circuits with this power supply on. Be careful. I'm going to turn it on. I'm going to put pin 1 low. So pin 1, the input switch 1 is low. So LED A should be off, LED B should be on, LED C should be off. If you take a look at your circuit, you always should have your circuit in front of you. Here it is. Your circuit's going to be in front of you. LED A is off, LED B is on, LED C is off. Now I'm going to turn switch 1 high. And notice when I do, LED A and C should be on. So, take it high. Notice what happens. I get LED AC and on. So this A and C are on. So the circuit's working fine. The circuit is working great. And what I'm going to have you do now on your own is turn this off. Once you verify what's happening here and you understand, and I want you to put in this third inverter out here with the extra 3 wires, or the extra 2 wires. You're going to need to do that. I also want you to notice that you have to have a schematic to build your circuits. I do not want you building schematics by looking at specifications. You look at your specs and you get your schematics drawn. If we're online and you want me to help you with your lab, the first thing I'm going to ask you is, where's your schematic? And if you can't show me a schematic of your design with these pinouts on it, I'm not going to help you. I'm only going to help those students that have a complete circuit drawn out with pinouts identified on the inputs and outputs. Then it's easy for me to help you troubleshoot your circuit. The final thing I want to mention is this handout here. You have to read this handout many times to fully appreciate this lab before you start. And in particular, I want you to look at page number 3. As I said before, the plus 5 volt power supply modules are not very fault tolerant and can be destroyed very easily if you are not careful with building your circuits. Below are the 5 most common ways you will damage this power supply. Number 1, you insert the module in backwards. You insert this module in backwards right here. You don't get this module put in correctly over here. That's a big problem. Be careful with it. Number 2, you insert chips in backwards. You put this chip in backwards, you're going to draw excessive current, you're going to blow that up. Students do it all the time in my face-to-face class. Biasing the chips incorrectly. If you don't have your VCC and your ground biasing the chips up correctly by looking at your specs to see which of these pins go to VCC and which of these go to ground, you're going to destroy the power supply. Making a mistake when connecting the 3 breadboards together electrically. If you don't get these 3 boards connected electrically together correctly and you short out any of those rails, you're going to blow up this power supply. Wiring your circuits wrong because you are not counting pins correctly. Being careless and not thinking clearly when stepping through these exercises I give you. Do not be in a hurry. Read each procedure a step at a time and think before you act. I already told you, if you slip up on any of the above, you could very well need to purchase a new 5 volt module on Amazon and get it ready as soon as possible. So I hope this first lab helps you out and gets you familiar with the way we're going to organize ourselves as we go through this particular laboratory remotely. The last thing I want to mention is turn off your circuit before you disassemble everything. And when you disassemble, I would always disassemble the white wires first. I'd always disassemble those white wires first. I would never mess with the red or the black because they're the ones that bias up everything. It would be ideal if you could actually keep what you see right here intact for 15 weeks. If you could just keep all this intact just like this for 15 weeks, that'd be terrific. because you wouldn't have to build it every time. Never tear the tear the switch assembly apart. We're going to use that every week. Never take apart the LED assembly. We're going to use that every week. And when you remove these chips, be careful. If you bend these pins a couple times, they'll break. That's why I give you a chip extractor. This little green chip extractor, what you're going to do, there it is. You're going to put it on each side of the chip, and you're going to rock it back and forth very gently, and you're going to remove the chip. And always inspect the pins, make sure they're okay. Now let me put it back in here. Make sure they're lined up, press it in, make sure it presses in the whole way. Now, use a chip extractor and you can very carefully take these out. My face-to-face class, what I let students do is I'll let them do this. Engineers do this all the time. I'll let them take a pen and pry this side just a little bit, or a pencil. And then take this side and pry it just a little bit, like that. And then go this side and pry it just a little bit so you don't bend it too much, and pop it out. I'll allow you to remove your chips using a pen or a pencil if you do it the way I just showed you. Otherwise, use the extractor. And that finishes up our first laboratory exercise, and hopefully, again, it'll familiarize you with everything we have here.